In Unit 3, Section 4, we're going to look at simplifying radicals, operations with radicals, and then also get into some rational or fractional exponents. So quite a bit involved here. First one we're going to do is number 1. Simplify square root 147. So okay, and again, that doesn't mean take your calculator and hit the square root button. It means you've got to break it down. Now, kind of the way I teach or show that is to take the number 147 and try and break it down into prime factorization. Okay, and if we're dealing with square roots, which is what you've dealt with in the past, now we're going to get into cube roots and higher, fourth roots and fifth roots. So if I break down 147, okay, it's 3 times 49. Okay, 3 goes into it. And then 49 is 7 times 7. Now, with a square root, remember that means the index is 2 right here. What we want to look at in this prime factorization is we want to look for pairs. I mean, this could really be written as the square root of 7 squared times 3. Now, I don't always write it like this. I look over here and I say, I've got a pair. I'm dealing with square root, index 2. So I can pull a 7 out in front of my square root radical, and then this 3 has to go back underneath, so it's 7 radical 3. So if you're dealing with square roots, you want to break them down and pull out any pairs that you have, which could be written as that number squared. So it's 7 radical 3. If we go down to number 10, now we're dealing with fifth root, plus we have some variables involved. So you still want to break down 256. So if I do 256, obviously I see that it's even. We could go 2 times 128. I see 128 is still even. So 2 times 64. Okay, and then 64 is 8 times 8, and both of those can be broken down into 2 and 4, 2 and 2, and then I have basically another 8 here. So that's going to be another 2 times 2 times 2. So what I want to do is I want to pick my pairs, and I've got all these numbers down here. There's all my numbers, and they're all 2s. Okay, and I can't miss any, so be careful when you're doing this. Now we're dealing with the index being 5 of the root, so fifth roots. So now I want to break them down into a group of 5. Okay, so I see this 2, so these 5, this one, this one, this one, this one, this one, could be written as 2 to the 5th, so I could pull a 2 out in front of my radical. Okay, so those 5, but I also have these 3 still left, so they have to go back under the radical, and it's the fifth root. So I'm going to put a 2 and a 2 and a 2, and they get multiplied back together under there, so that is 8. Now, x to the 8th could be written as x to the 5th times x to the 3rd. Why did I do that? Because I can take the fifth root of x to the 5th. That's going to pull an x out in front. It's going to leave me with that x cubed still underneath there. And then I also have this y, and it's to the 1st, so I can't pull any y's out. So it's 2x out in front of my radical, fifth root of 8x cubed y.